Hello everyone, I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about Laplace Transform of Differentiation Theorem. This is lecture series on control systems, mathematics, network theory, power systems, and lecture number 8. So our topic's name Laplace Transform of Differentiation Theorem. Differentiation theorem in Laplace transform formula. Let f of t be a function of t and let f of s be its Laplace transform. The Laplace transform of the first order, second order, third order, and higher order derivatives are. So in this session, our function f of t. This is our function f of t. Laplace transform of f of t equals to f of s. Laplace transform of f of t equals to f of s. This is the time domain function and this is the frequency domain function. So this is the conversion time domain to frequency domain. In inverse Laplace transform, frequency domain to time domain function. And where s is equal to sigma plus j omega, sigma plus j omega, where sigma equals to real part of s and omega equals to imaginary part of s. Sigma, the unit of sigma equals to Newton and unit of omega equals to rad per second. So in this session, differentiation theorem for first order systems. What is the first order system? If function equals to f, if function equals to f of t, then first order system means d dt of df of t by dt equals to first order systems. So Laplace transform of first order differentiation. This is the f of t function and df of t by dt is called differentiation theorem of first order systems. And this is equals to s into fs minus f of 0, f of 0. And differentiation theorem for second order systems, this is the second order system. If function equals to f of t, then d2 f of t by dt2 equals to s square f of s minus s f of 0 minus f dash 0. This is the second order systems. And for third order differential equation, differentiation theorem for third order systems, Laplace transform of d3 f of t by dt3 equals to s cube f of s minus s square f of 0 minus s f of f prime or f dash 0 equals to f double dash 0. This is the third order systems or third order differential equation and Laplace transform of third order differential equation. And differentiation theorem for nth order systems. What is the nth order systems? Again, f of t is the function and dn f of t divided by dt to the power n equals to s to the power n f of s minus s to the power n minus 1 f of 0 minus s to the power n minus 2 f prime 0 and minus dot 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 minus s f to the power n minus 2 double prime 0 minus f to the power n minus 1 prime 0. If all initial conditions are zeros, that means f of 0, 0, this term 0, this term 0, then d3 f of t, Laplace transform of d3 f of t by dt3 equals to s cube f of s. Similarly, if all initial conditions are zeros, this term, this term, this term, this term, all are zeros, then Laplace transform of f of t equals to Laplace transform of d to the power n f of t by dt to the power n. This is the nth order differential equation. Laplace transform of first order differential equation. This is the very important formula. Laplace transform of df of t by dt. This is the first order differential equation. If f of t is the function, then df of t by dt is called first order differential equation. And this first order Laplace transform of this first order differential equation equals to s f of s minus f of 0. If f of 0 equals to 0, then Laplace transform of first order differential equation equals to this part. Laplace transform of df of t by dt equals to s into f of s. So prove that. Differentiation theorem. What is the differentiation theorem? Let f of t, this is the f of t, be a function of t, and let f of s be its Laplace transform. That means if f of t is the function of t and Laplace transform of f of t equals to f of s. Laplace transform of f of t equals to f of s. The Laplace transform of the first order differential derivative of f of t is given as this. Laplace transform of df of t by dt equals to s f of s minus f of 0, where f of 0 is the value of f of t at t equals to 0. Then what is the Laplace transform formula or formal definition? The Laplace transform of a time domain function f of t, which is defined for all real number t greater than equals to 0. That means this function satisfied only t equals to 0 or t greater than 0. That means positive time. It is assumed that the value of the function is 0 for t less than 0. That means negative time equivalent to 0 value. If t origin is that t equals to 0 and this side plus infinity, this side minus infinity, Laplace transform satisfied only t equals to 0 to t equals to plus infinity, and does not satisfied or the value of the function is 0, this region. And this is also unilateral transform because only satisfied 0 to infinity, not minus infinity to plus infinity. And the Laplace transform of the time domain function f of t is given by Laplace transform of f of t equals to f of s equals to 0 to infinity f of t function of t, f of t equals to e to the power minus st dt, and symbol L stands for Laplace transform of. This is the Laplace transform of. That means Laplace transform of function of t or Laplace transform of f of t equals to 0 to infinity f of t to the power minus st dt. Already discussed, s is equal to sigma plus j omega, and sigma is the real part of s and omega is the real part, imaginary part of the s. And this is the time domain to frequency domain conversation. And in this case, by Laplace transform definition, Laplace transform of f of t equals to f of s 0 to infinity f of t e to the power minus st dt, where f of t equals to dft by dt, because this is the first order differential equation or first order derivative. So f of t, function of f of t equals to dft by dt. So put here dft by dt and put here dft by dt. Then we get, put f of t equals to dft by dt and we get put here dft by dt, f of t equals to dft by dt, and this is also dft by dt because definition f of t to the power minus st dt. So f of t equals to what? F of t equals to dft by dt. Then integrate. Suppose this is the first function. This is first function and this is the second function. This is 1st first function and this is second function. So first function constant, e to the power minus st constant, this is first function, this is constant, and second function integration dft by dt, integration up to 0 to infinity minus 0 to infinity first function differentiation. This is the first function differentiation, and second function integration up to 0 to infinity. This is UV method. So e to the power minus st 0 to infinity df of t by dt into dt minus 0 to infinity ddt of e to the power minus st. This is the first function differentiation, integration df of t by dt into dt whole into dt. So this is the integration form. And then e to the power minus st df of t by dt cancel. This dt and this dt cancel. Again this dt and this dt cancel. So e to the power minus st. This is the e to the power minus st. And dt cancel. That means only d of ft. So this is integration 0 to infinity d of ft. And e to the power minus st, e to the power minus st integration differentiation, and this term dt cancel, integration d of ft whole into dt. Then integrate and we get just e to the power minus st constant. This is fixed, and then d of ft is d of something equals to something. So here d of f of t equals to only f of t, and limit 0 to infinity, upper limit infinity, lower limit 0, then minus 0 to infinity, e to the power minus st equals to what? E to the power minus st equals to minus s into e to the power minus st. So differentiation of dt e to the power minus st equals to minus s into e to the power minus st, and d of function equals to function, that means f of t. Then this is the integration, and then put upper limit equals to infinity. So put here t tends to infinity, e to the power minus infinity f of infinity minus e to the power 0 and into f of 0, and something to the power infinity is 0 and something to the power 0 equals to 1. Then s common, minus plus, and e to the power minus st into f of t. This is equivalent to ultimate f of t. This is equivalent to f of s, or f of t, f of s. This is equivalent to f of s. So in this case, this value 0. This is the 0, and this is 1, and f of 0, initial value 0, s constant, and this term equals to f of s. This term equals to f of s, because f of s equals to 0 to infinity f of t into e to the power minus st dt by definition. This is by definition. Then what is the ultimate formula? Then f of t equals to Laplace transform of f of t equals to f of s equals to Laplace transform of df of t by dt equals to minus of f of 0 plus s of fs, or Laplace transform of dft by dt equals to s fs minus f of 0. This is the very important formula for Laplace transform first order differential equation. This is the first order differential equation. If f of 0 equals to 0, suppose this function equals to 0, then that means initial condition 0, then L of dft by dt equals to only s into f of s, when initial conditions 0. Similarly, for second order differential equation, Laplace transform of second order derivative. Second order derivative means Laplace transform of d2ft by dt2 equals to s square f of s minus s f of 0 minus f prime or f dash 0. Prove that. What is the differentiation theorem? Let f of t be a function of t, and let f of s be its Laplace transform. The Laplace transform of the second order derivative of f of t equals to d2ft by dt2, So function d2ft by dt2 by Laplace transform definition. What is the definition? Laplace transform of f of t equals to f of s equals to 0 to infinity f of t e to the power minus st dt. This is the definition, where f of t equals to second order differentiation terms d2ft by dt2. So put here f of t equals to d2ft by dt2, and put here f of t equals to d2ft by dt2. This is the form. Laplace transform of d2ft by dt2 equals to f of s, and integration 0 to infinity d2ft by dt2 e to the power minus st dt. Again, UV method integration. First function e to the power minus st. So this is u, and this is the integration term, second term integration, and again first term derivative, second term integration, and then we get e to the power minus st. This is the e to the power minus st, e to the power minus st, and this is the d2ft by dt2. That means ddt into dft by dt into dt, and ddt of e to the power minus st, and in this case ddt of dft by dt whole into dt. This is the just arrangement. Then we get e to the power minus st, 0 to infinity d of dft by dt minus 0 to infinity ddt of e to the power minus st integration d of ft by dt whole into dt. And in this case d of something, that means integration something. Second case, e to the power minus st, that means derivative minus s and into e to the power minus st, and d of something, this is the d of function, d of something equivalent to something. So d of dft by dt equals to dft by dt, d of dft by dt equals to dft by dt. Then put upper limit and lower limit, and we get, just put infinity, in this case e to the minus s into infinity df of infinity by dt minus lower limit e to the power minus s into 0 df of 0, just put here 0, just put here lower limit 0. Then this is the first case, and s minus plus s, and e to the power minus st d of ft by dt. This is the first order differentiation form. So put here the value of this s into fs, because Laplace transform of dft by dt equals to s into fs minus f of 0. Just put this value in this position, and we get, this is the 0 value, and this is the f dash value, this is the 0 value, and this is the 1, and this is the f dash 0, and plus s into fs minus f of 0. Then we get ultimate minus f dash 0 plus s square fs minus s f of 0. Just arrange s square f of s minus s into f of 0 minus f prime 0. So Laplace transform of f of t function equals to Laplace transform of d2 f of t by dt2. This is a second order differential equation, and we get s square f of s minus s into f0 minus f prime 0. This is the second order differentiation for Laplace transform, second order differentiation Laplace transform, s square fs minus s into f0 minus f prime 0 if all initial conditions zeros. That means f of 0 equals to 0, then Laplace transform of d2ft by dt2 equals to s square f of s. This is the second order differential equation. Then prove third order differential equation, Laplace transform of third order differential equation. What is the third order form? Just f of t equals to d3 f of t by dt3 equals to prove s cube f of s minus s square f of 0 minus s f prime 0 minus f double prime 0. So this is the third order differentiation form. Prove this. This is the form. Then differentiation theorem, let f of t, this is the f of t, be a function of t, and let f of s be its Laplace transform. That means Laplace transform of f of t equals to f of s. The Laplace transform of the third order derivative of f of t equals to d3 f of t by dt3, and by Laplace transform Definition: Laplace transform of f of t equals to f of s equals to 0 to infinity f of t e to the power minus st dt. This is the definition of Laplace transform. For third order systems, just put f of t equals to d2ft by d3ft by dt3, d3ft by dt3, put here d3ft by dt3, and we get, just put here f of t equals to d3ft by dt3, and we get Laplace transform of t equals to f of s equals to 0 to infinity d3ft by dt3 e to the power minus st. Just put here d3f of t by dt3. Then we get this is the form: Laplace transform of d3ft by dt3 f of s equals to 0 to infinity d3ft by dt3 e to the power minus st dt, and then integrate, just integrate. What is the integration? This is the first function. This is the first function. Just this is the first function. So first function, this is first function. Second function, integration 0 to infinity. Again first function derivative, and second function integration. This is the UV method, integration UV method. So e to the power minus st 0 to infinity d3 f of t dt3 dt, and 0 to infinity first function differentiation ddt e to the power minus st integration d3 f of t by dt3 dt whole into dt. This is the form of UV. Then just integrate, and we get this is the e to the power minus st, e to the power minus st, this term constant, and then ddt of what? This value equals to ddt of d2 f of t by dt2 whole into dt. Similarly, this is the derivative term, first order differentiation terms, and again this terms equals to ddt into d2ft by dt2 whole into dt into dt. So this is just arrangement, and then integrate e to the power minus st, first function e to the power minus st, and d of something, or d of function equals to, this is the d of function. So this is the integration, and second term 0 to infinity, this derivative equals to minus s e to the power minus st, and d of something equivalent to something. So this is the d2ft by dt2, and then put upper limit infinity and lower limit 0, and we get, just put here infinity, first term infinity, upper limit infinity, second term lower limit 0. Again 0 to infinity e to the power minus st d2 f of t dt2 whole into dt. This is the second order differentiation terms. So put here second order value, just s square fs minus s into f0 minus f prime in this position. This is the second order case, and in this position put this value, because Laplace transform of d2 f of t by dt2 equals to s square fs minus s into f of 0 minus f prime 0. So this is the second order differentiation form, and then multiplying by s, and we get minus f double prime 0 plus s cube f of s minus s square f of 0 minus s f prime 0 minus s f prime 0. Rearrange, and this is the first term s cube f of s minus s square f of 0 minus s into f prime 0 minus f double prime 0. This is for third order differential equation, Laplace transform of third order differential equation. So Laplace transform of d3 f of t by dt3 equals to s cube f of s minus s square f of 0 minus s f prime 0 minus f double prime 0. This is the Laplace transform for third order differential equation, or third order terms. If f of 0 equals to 0, then this terms equals to 0, this terms equals to 0, this terms equals to 0. Only Laplace transform of d3 f of t by dt3 equals to s cube into f of s. This is for f0 equals to 0. F of 0 equals to 0. This is for. Similarly, for fourth order, fifth order, five order, sixth order, seventh order, and dot 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 nth order differential equation. This is the nth order derivative, Laplace transform of nth order derivative. What is the differentiation theorem? Let f of t be the function of t, and let f of s be the Laplace transform. The Laplace transform of third order derivative, not third, this is nth order derivative. This is the nth order derivative, not third, nth order derivative. F of t equals to dn f of t by dt to the power n. This is the nth order differentiation terms. Then similarly, Laplace transform of f of t equals to Laplace transform of d n f of t by dt to the power n equals to s to the power n f of s minus s to the power n minus 1 f of 0 minus s to the power n minus 2 f prime 0 dot 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 minus s square f to the power n minus 3 triple dash 0 minus s f to the power n minus 2 double prime 0 and minus f of f to the power n minus 1 prime 0. This is for nth order derivative terms or nth order differentiation terms. Laplace transform of dn f of t by d to the power n equals to this value. When initial conditions are 0, that means this value 0, this value 0, this value 0, this value 0, this value 0. Only Laplace transform of d to the power n f of t by dn dtn equals to only s to the power n f of s. This is for nth order differential equation. So thank you.